presentation is from Gregory Denis. I hope I pronounced the name correctly. He's a senior computer engineer and works for the Caltech Institute. Is been one of the main developers of the VRVS research team since 1997, and he's going to give a talk about VRVS, global platform for rich media conferencing and collaboration. Gregory, hope you can hear him.
Gregory, can you hear us?
Yeah, I can hear you.
Yeah.
Okay.
Hello, can you hear me?
Yeah, absolutely, perfectly. Please start.
Okay, can I start?
Yep, the floor is yours.
Yes, please.
Okay. So, welcome everybody. My name is Gregory Denis, and I'm working for Caltech, the California Institute of Technology. And I'm very happy to present finally this presentation. Well, at least remotely, but it's a nice demonstration for that technology. So I hope that you are seeing my slides right now. So I will move on.
Yes.
So first of all, I will tell you a little bit about the description of the current system that is a video conferencing system called VRVS. After that, I will tell you more about the current status and how it's used by our user right now. And then we will see what the new feature we will add very soon during this summer. And finally, I will give you information about the development that we are proceeding for the next few months. So what is VRVS? VRVS is a software system that provides a video conferencing system over the IP network. It provides more than this. It provides also several services like sharing, web conferencing, and different tools that I will describe later. This system is based on two components. One is a network of interconnected reflectors around the world. Another one is a centralized web server that provides all the interface and all the facilities to the user. Our system is based to provide a multi-point and point-to-point conference for everybody on the planet. We try to make it easy as possible and provide everything that the user needs as documentation, way to change their profile and give support and provide some provide some expertise about our test on hardware and software. Well, VRVS is really easy to use, at least is what we try to reach. So the only things you have to do is go to the web server, is www.vrvs.org, and everything should be and could be done on your web server, whatever is your platform. You just have to register, click on the button to scheduling your meeting, join the meeting, and click on icon to start. The main thing is we want to hide all the complexity of the technology that is really difficult to understand for someone that is not a technical expert in these video conferencing things. VRVS is also an open system. I mean, we're trying to integrate everything, every technology, every standard, and make it interoperability between all these pieces of things that makes the user confusing. So we provide services that allow users choose their own standard, their own client that they want to use because they prefer this, or someone buy already this kind of client, hardware or software. So we have a list here of all the clients that we support right now. But we provide extra features. We provide a full sharing services for each meeting, and this sharing is multi-platform. I mean, someone can share his Macintosh application to a Unix and PC's Windows participant. We made some feature to remove the limitation of the H323. H323 client now can select the video that he wants to see, not only the video of the current speaker. He can see also with a PC at the same time all the video of all the participants at the same time. We provide a chat services where the user can also have a web browsing experience with the others. We provide all the documentation and the recommendation for our user community. So here you see an instance of our current web user interface. So on the top you can see the name of the virtual room, the name of the meeting. The user can see the date and time convert to his time zone. You can see in the middle all the participants that are currently connected, and in one shot is able to see where are connected the participants and which services or facilities we're using. On the bottom, at the bottom, you have all the icons that let the user start the tool they need to start the video and audio, depending of the type of client he wants to start, and also the other services like the chat and the sharing. Well, let's speak deeply in detail with the architecture of the system. We can split in different layers. First, the bottom layers is the TCP UDP IP network that we are using, and upper that we are using with our reflector technology, the Rtcp and Rtp, to encapsulate the audio, video, and data streams, and our reflector working in unicast and multicast protocol. So upper you have all the technology standard and applications that are working as a client, like all the H323 client, let's say Mbone, Vic, RAT tools, MPEG, SIP, QuickTime. And on the top, we provide a HTML and web interface to provide something really easy for the user to understand and operate. This is an example of a session. It's on the Linux laptop. So this user is using RAT and VIC, called yesterday Mbone tools. And so the only thing that this person has to do is use the web interface, and when he clicks, it's starting the right application on his desktop. Of course, this person can use at the same time H323 client, external or internal, and it will work at the same way. I will just say a few things about Access Grid. I will not describe Access Grid, but just for the people who knows what is Access Grid, I just want to say that we provide the only one solution for the desktop and H323 client to participate to Access Grid meetings without spending $40,000 for an Access Grid node. So with this system, you can participate with limited bandwidth as a normal bandwidth, and then participate with the Access Grid virtual venue. And this table just show you the difference between VRVS and Access Grid, and what we made is to incorporate the Access Grid technology to our services, and then provide to our user a way to enter to the Access Grid conference. So now let's talk about the way the user use right now the system. Up to now, there's 6,300 users spread around 60 countries around the world. They making 8,000 hours of multi-point conferencing during the last year, and around 1,100 hours per month since the last three months. So here you can see the growth of the user since a period of 2 years and a half. And here you can see the number of hours, multi-point hours per year. So the brown one is this year. So you can see how the system is used. More we go, and more we have users. So here is the average on this meeting are 4 to 10 participants, but we are not limited in participant number. So sometimes it can go up to 40 participants at the same time. Here is the infrastructure we deployed to give a better access to all our users, and then optimize the bandwidth and the routing. So it's our 43 reflectors that we spread around the world. And VRVS has been chosen as an Internet 2 application, so to provide to our Internet 2 community a better services, we installed 7 reflectors in the main interconnected point of Abilene network. So now let's talk about the new version of VRVS that will be released this summer. As you saw, the use of VRVS is increasing too fast for us, so we have to face this success and try to give the same quality of service that we provide in the past. So we decide to rebuild the main base of the system and improve the speed, add authentication, and encrypt the sensitive data, and the most important for our user, provide a big number of virtual rooms, because right now most of them are fully booked during 2 months before. So we will provide something that will be able to handle several communities and hundreds of virtual rooms. To do so, we move to a professional database engine and rewrite all our code to improve the speed. We also worked on the reflector to improve the H323 interconnection with the other clients, do packet recovery, because most of H323 clients are more sensitive in packet loss than a normal M-Bone, for instance, or QuickTime or GMF clients. And we try to fix incompatibility between endpoints, because each manufacturer makes its own H323 implementation, so we have to deal with all these things. We have improved also the way to detect the end client through the web cache, the Rtcp and firewall and so on, and try to give something that is more easy and can be used for the most web browser available. This new version will support all the time zone and make the TST summer times automatically switch. We redesigned completely the interface to deal with all these communities and hundreds of virtual rooms, and to be able for the user to find quickly the meeting he wants to join, or to find quickly an empty space in a virtual room to book. As I told you, we improve the authentication and the encryption, and now with this authentication process, the profile will follow the user, whatever the computer in the world he will use. This is an example of the new interface. that we will release soon. On the top, so the user can select dynamically his community. The virtual room belongs to that community. He can change his time zone dynamically, and then all the date and time that are shown on the interface automatically convert to his selected time zone. This is an instance of user profile. So you can see that we add also some quota in the booking. So the booking, this is, I think, one of the most important parts that we improve. As I told you, the time zone now is taking care automatically of what you select. You have a back quota to be able to allow in better way a way to the user to find a meeting in the virtual room. We have a locking system, we have mailing list. Now the person can put a mailing list, and then all the interaction he will make with his reservation will be forwarded to the mailing list. The user can choose also among different bandwidth range, because imagine that that his participant will have low bandwidth capacity, so he wants to reduce the maximum of bandwidth that the user can send video and audio. So this is the kind of thing that he will be able to do. We will provide also copy and move of booking to a different date and place. This is another instance of this interface that allow the person to change the beginning or the end of his booking, or move to another date or copy another date. This is the month view of the booking system. So we just have to click on the cell, and then it will see exactly the conference this day and book another one if he wants. This is another one that allow the user to see for a specific date which conference will occurs and what kind of option have been selected for this one, and so on. And all the date and time are computed automatically in his time zone. So what's about the future? Here I will describe the future development that we are in the box, and we want to work on it. So first of all, we will work to be IPv6 compatible as soon as we can. So the new version that will be released is at least practically IPv6 ready. So we will have to work a little bit in the reflector and make tests to be sure that everything works fine. Also, we saw that the SIP client start to be more mature, and we will work on that client. And when we'll see that these clients are ready to be integrated, we will work on that aspect to provide to the user this option to join the VRVS meeting. We will work also with the interoperability with the other infrastructure, and especially the H323 infrastructure, because now more and more people start to create some H323 MCU cascading and gatekeepers. So we want to be a part of this infrastructure. So we will make some gateway and provide some way for the user to interconnect with H323 world. And also we would like to provide a way for our database to exchange the user data with the LDAP servers. And one main thing is the security, and we have to deal with firewall and network address translation. We already start to work on that part, and we hope to release something in several months that will fix all these problems. We will add some intelligence in our reflector that give them the way to dynamically routing the stream depending of the traffic, the network and the congestion, and also to know if this reflector is up or not. For the administrative point of view, we will add some module to know dynamically the bandwidth available for that reflector, the CPU and memory use, and so on. We start and we will continue to work on the mobile and wireless client, and we will work on a specific interface to fit their small screen, and we work to provide some video conferencing client for this specific device, at least to be able to assist to conference and perhaps to be able to participate to this conference. So to resume, I will just say that VRVS is not a prototype. It's a worldwide video conferencing services since 5 years now. This new version will be released this summer, and our team still to work to integrate all the technology that will help the user to make their meeting better. And new starter of art still the same, easy to use for the user. And the only thing I should say, go to the web server and you will see, try our system. That's all.
Thank you, Gregory.
Have you any questions?
So we have at least 5 minutes time for questions.
I can't hear you.
You can't hear me. Can you hear me now?
I cannot hear you.
We have about 5 minutes for questions, if you want to take any. Can you hear us? Hello?
The person with the orange short t-shirt I can hear. Perhaps, can you try?
We have about 5 minutes for questions.
No.
No.
Can't hear us. Hello?
It's working fine. Can you hear me now?
Yes, I
Yes.
can hear you.
Okay, so it's not the microphone, I'm afraid. Okay, we were trying to say that we have about 5 minutes for questions, and yeah, is there anybody in the floor who has questions for Gregory? Yeah, one over there.
Hi, Gregory. We know that VRVS is and was developed by Caltech at CERN in the public domain. Now there are some developments that also commercial VRVS clients come up. Does that hamper development in any way? Will it still be available for free for higher education and research? Can you tell us something about that?
Okay. So first of all, I would like to correct a little bit some parts you said. We are working for Caltech, and VRVS, it's a Caltech property. It's not an open source. We provide a service for the Rtcp and research and education community. VRVS is not a client. It's just an infrastructure that give to the user the ability to start from any client, open source or manufacturer client, to start a video conference. Right now, nothing has been started in a commercial point of view. And anyway, if in the future something starts with the VRVS technology, Caltech still continue to provide these services for the Rtcp, high energy physics community, and education and research community for free.
Okay, thank you. There any other questions? Yeah, Egon again?
Yeah, I just go on with asking questions until somebody stop me and ask another question. The first one is, we know that you've been experimenting and have support also for MPEG-2, and especially the Minerva box. Can you say something about the support for other MPEG clients?
Yes. We made the first MPEG-2 MCU, multi-point MCU in the world. Unfortunately, nobody using it. Especially because Minerva was not pushing on on their box to sell to the education community, and also because their box are really expensive. So we stopped the development on that part, and we are looking at the new PCI card that making MPEG-2 compression, decompression in real time. But I would say that our future development will be more focused on MPEG-4, that will probably fit more on the bandwidth for all the kind of scenario.
Another question?
Well, yeah, if there's time and nobody else has. You did mention security. Now we know that secure multicast is a really hard problem, and it's not been solved. And there are big fights in the IETF to come up with a secure multicast protocol. So I was wondering, can you say a little more on the way you think you can provide some security?
Okay. First of all, with VRVS, you have the choice when you install some reflector in your side to choose between multicast and unicast. Most of VRVS reflectors are interconnected in unicast. In security part, I would say that we will work on tunneling to remove at the maximum we can the number of parts used, and we will see with a specific commercial product that's working for H323 to make these things to dealing with NAT and to dealing with NAT and firewall, to see if we can find a way to integrate this commercial product and use in the VRVS infrastructure.
Okay. Thank you.
But I can say that for video conferencing, the security is a real problem. When you start when you want to exchange things, video, audio, and data, the problem you have to open port to the rest of the world, and this problem is the same for everybody, and especially the commercial part has the same problem.
Okay, thank you, Gregory. I'd like to stop the question now and move forward to the second talk. It's going to be presented by Eva Hladká and Petr Holub from Masaryk University.
I can't hear you.
Just a second. Gregory, we move forward to the following. Okay. We move forward to the following talk. So thank you very much for your presentation.
Okay, you're welcome. Bye-bye.
Right, let me properly introduce the next talk. Eva graduated in mathematical informatics and worked as network administrator and head of information technology unit after she entered a PhD study program at Faculty of Informatics at Masaryk, University of Brno. And her current interests are active networks, video conferencing, and collaborative technologies. And Petr graduated in physical chemistry from the Faculty of Science, Brno again, and now works at the Institute of Computer Science of the same university. His research interests are high-speed networking, security, and video systems. And they're going to present us an alternative approach, I would say, talk about teleconferencing support for small groups.
Thank you for your introduction. My name is Eva Hladká, here is Petr Holub, and we are from Faculty of Informatics, Masaryk University, but also partly from CESNET organization, which provides academic networks in Czech Republic. Our presentation will be about teleconferencing support for small groups. for introduction, what is target environment for our work? At first, we have multitude of small groups with all active members for teleconferencing or videoconferencing as virtual working meetings. The main idea was to have group communication without special network services needed, because we have a lot of experiences with multicast and N-bone, and N-bone is not still good environment for serious work. It's good for experiments and so on, but not for serious work. The next target was diverse computer system platforms of our users, because somebody like Windows, somebody like Linux or Sonos and so on, somebody has PC, somebody workstation of SGI or Sun and so on. Interesting was that our users are from computer science community, especially the main of them was from Czech data grid part, and these users has interesting features because they like to use computers, then they know how computers work, how to use them, but on the other side, they have non-trivial demands for usage computers, and then they don't like the answer that it's not possible to do something. And one of targets was also to provide reasonable security. And as was in previous lecture, group community is problem now. And for the system was necessary new features to be easily added. It's input of the user community.
Well, so what we have chosen? We have chosen to use open source software and to produce open source software. That's the major difference between us and between VRVS, which is producing a service. That means they are producing sort of black box. You can peek inside, and sometimes it's hard to handle. We decided to use N-bone tools, that's VCRET and WBD for shared whiteboard, because they are able to cover a multitude of different platforms, especially different Unixes and Microsoft Windows platform. Our primary decision was to replace multicast by mirrored unicast by reflector technology. Probably a lot of us have their experiences with the problems with multicast on their networks. You can make your network administrators to improve that situation, but it's unstable. Usually multicast is the very first service to be cut off when some networking problems occur. And for administrative purposes, we have chosen web environment as well as VRVS does. For network support and for communication, we decided to use very simple packet reflector called RAM. It was originally done by Julian Highfield, and this tool does just a very simple thing. All the packets coming on to one port mirrors to all the other ports, to all the clients, all the active clients on the same ports.
I want to say that the simple UDP packet reflector is about 200 rows in source C code, nothing more.
Yeah. And therefore we have moved the services from network level to an application level. We think it's quite important because trends in modern high-speed networking usually end up with very fast but very simple networks, and all the network intelligence is being moved toward the application level. When using those tools on application level, you have features like easy modification. You need no iOS, Cisco iOS downloads and uploads for the boxes, no network instability, no network clashes, and all is up to you what modifications you do. On the other hand, you face to worse scalability and efficiency, though we think we can handle this problem.
And our system was decided to small groups, so the problem of scalability is not so important for us. Here is a small animation for those who are not familiar with multicast and UDP packet reflector. At first, multicast, when all activities inside the network, and network is responsible for making copies and transfer them to end.
So the model of multicast is that one data over one link, and data multiplication occurs on network active elements.
Yes, and now how works reflector? Data goes from MPC to the server. Server makes copies and sends it to empty PC. From this side of view, it's worse, but in practice, it's better.
It works.
Yeah.
After some initial experiences with Reflector, we realized that we need some security features. First of all, we decided to do some authentication and authorization based on IP addresses. You may specify what IP addresses or subnets are allowed to participate, and also some authentication authorization based on username password combination. Furthermore, we needed to have some logging to track down problems occurring during the conference. By the way, that's one of the things I'm really missing in VRVS system. This can be seen as sort of merge of H323 MCU and basic gatekeeper functions. Other features we have added to the Reflector was data recording. You can record the session and later on you can replay it.
Sorry?
The other way around. We think that web environment is the most common environment for most of our users, so we decided naturally to use web as an administrative environment. We haven't implemented much fancy features, but rather simple ones and useful ones.
Without pictures and without more clicking.
By conference, we mean one or more instances of reflectors.
Because each tool needs own reflector. So if we use video, audio, and WBD, we need 3 instances of UDP packet reflector.
We have 2 roles for the people. First is administrator. That's a person that sets up and manages user accounts, and then the user who's actual administrator of the conference. So user can set up the conference, run the conference, stop the conference, view the log activity, and all the things. So the conference setup looks like user logs in into the web portal, sets the parameters required for the conference. That includes a number of reflectors necessary for the conference, logging features, descriptions, scheduled time, and allowed and denied IP addresses and users.
And also signals for recording or stop recording. Running the conference, what is running the conference announcement can be seen in public part of our web. Conference is starting manually or scheduled. The feature scheduled starting conference is just in testing, so now it's necessary for users to start conference manually, and conference administrator can browse log file during the whole conference, so he can see what is done just now.
Here are some examples of some sample screens from the web administration interface.
It's public part.
It's public part of the web. This is the announcement screen. The next one is conference setup. Could you advance?
Okay.
This is the conference setup, or this is mirror setup.
Mirror setup, where is port number using protocol. You can work authorization method, encryption key, log file, and so on. So in this part, you can prepare your own reflector with features you want.
And this is the conference administration, so you can start it, edit it, delete it, or view the log file. Just simple.
Okay.
We have done several enhancements in Embone tools, especially in shared whiteboard. The other tools like Vic and Red are quite mature and quite stable. Oh, no, the stability is a bit of question, especially under Windows environment. But anyway,
but it's quite sufficient.
Yeah, it's quite sufficient. But the shared whiteboard was a real problem. Currently available are two versions of Embone tools, WB, which is the problem that's missing source code availability, and the WBD that had less features, but that was available in source code. So we have chosen WBD, and we decided to enhance its capabilities a bit. So we have implemented security. It's the same as in Red and Vic tools. It's available either using DES encryption or Rindle encryption. We have added support for additional image formats, especially JPEG and GIF and other formats. Originally it was possible to import PostScript, just very simple PostScript and plain text only. We have added zoom features, synchronized rotation of image, and faster drawing of the image, and also faster network transmission, since the original version of WBD was limited to 30 kilobits per second approximately.
Adding new features and especially new formats to the WBD was demand of physicians, especially pathologists, because when they want to make teleconsultancy, they need a good shared workplace with including pictures from microscope. Here you can see example of WBD with imported JPEG.
And the next slide is example of zoom capability.
Yeah. This tool is implemented now only under Linux, but we plan to port it to the Windows.
And here is an example of a whole conference, except for whiteboard, because it wouldn't fit in this screen. So many windows of VIC tool, video tool, and Red tool. Next.
Here we have 4 places connected via UDP reflector, and upper is seen that the VIC tool is started not with multicast address, but with address of reflector and port on server with reflector.
So the further development of our reflector includes first tunneling that improves 2 things. First, scalability is the same issue as for VRVS. And the same technology we are able to use for, as we say, unfriendly environments. That's for a firewalled environment. Because often you encounter environments when only HTTP protocol, port number 80, or SSH protocol is allowed. And you need to use other ports as well. And we use this tunneling technology, and we can tunnel it through arbitrary port. This thing is already done. It's not further development. Further development is stream synchronization on mirror, because we are working on three-dimensional projection, so you need quite accurate stream synchronization, and we are working on publishing information about reflectors into LDAP to be able to give a user notion of what conferences are running throughout the world.
Strong security for group communications is also a problem. When we started to work on Reflector, we started to collaborate with a group from military academy, and they developed very secure video conferencing environment based on unicast UDP packet reflector and M-bound tools with a strong cryptography library.
As with any additional processing, you face increase of latency, but they made it really well, and it's
it depends on
it's
complexity of cryptographic function.
So our development was, some conclusions as our development was motivated by two factors: unavailability and instability of multicasting network, and video conferencing needs of several small groups on Masaryk University and CESNET, especially the European Union Data Grid project, the Czech group of this project, and CESNET groups. We think our software has been tested thoroughly during almost last year and a half, and we have found many different problems with a lot of things, but not with the reflector. The reflector is rock solid and works. We have encountered many audio and such problems, but this technology seems to work well.
And I must say that when we started, only this group of Czech part of Data Grid was our user, but now we have several groups and the number is growing.
As with all the video conferencing systems, to have a nice experience with it, you need reasonable equipment for audio and video, especially when capturing audio in larger rooms. And underlying network must have sufficient bandwidth to cope with data multiplication.
Because video conferencing is typical end-to-end service, so you need bandwidth from end to end. Now, acknowledgements. We want to thank Czech group participating in EU Data Grid, especially for passions with testing our system. Luděk Matiska, which is here, for many ideas. Zdeněk Salvet for network support, and CESNET research item for financial support. And last but not least, thank you for your attention, and if you have questions, now it's possible.
Thank you, Eva and Petr. Questions from that side of the room?
Okay.
Okay, hello. How many people at most have you tried with the reflector? Because I understand it's kind of a bottleneck, so how wide is this bottleneck?
In fact, reflector is stopped when number of connecting places is more than 64. In reality, it depends on bandwidth from each place. So we try to use it when 7 places and more than 10 megabits was processed, and was not problem.
Scalability of the system by tunneling, that's why we are focusing on multi-topic. So we have run this with 40 places connected to one mirror and 40 applications connected to one mirror, and it works well.
And in fact, it works well every Friday from 10 when Czech Data Grid Park had weekly meeting.
Okay, there was another question here, just up.
Hi, thank you. It's a very interesting approach. Is there documentation available in English?
Yeah. In proceedings, you can find all about the system, all addresses, because all is open. You can find all software and all information at network.
Okay, and the second question is, you mentioned the problems with the deployment of multicast network, and that's why you do the mirroring and the replication. But do you also support now a unicast multicast network for those people that are on a multicast network? And if you have a reflector on a multicast network, that you can use as much multicast as possible, but only for those that cannot use the unicast?
I think that unicast can use all people's on internet. So we concern on unicast connectivity. In fact, in future it will be possible to combine unicast and multicast, but now we are sufficient with mirroring.
Any more questions? Okay, we don't have any more questions. Thank you very much. The next talk is about a paper which has been presented by Maja Matijasevic, assistant professor at the University of Zagreb, and Leah Skorin-Kapov from Ericsson, Croatia. And Leah is the one who's going to make this presentation. Leah is employed as a research engineer in the Research and Development Center of Ericsson in Croatia. She received her degree from the University of Zagreb in Croatia in 2001, and she's currently working towards a master's degree in the area of network virtual reality. Her main research interests include quality of service, virtual reality, and streaming, and she's a member of the IEEE Communication Society. The title of this paper is Design and Evaluation of a Multi-User Virtual Audio Chat. And the floor is yours.
Okay. Thank you very much for your introduction. My name is Leah Skorin-Kapov, and this is a joint paper with Professor Maja Matijasevic entitled Design and Evaluation of a Multi-User Virtual Audio Chat. In this presentation, I would first like to just give a short introduction to state what virtual reality is and what the issues are determining the quality of service requirements of virtual reality services. Next, I would like to mention how previous research has addressed these issues and what our approach has been in this area. Within the scope of this paper, a simple multi-user interactive prototype application in the form of a virtual reality and web application has been developed that we call the virtual audio chat, and a performance evaluation has been conducted addressing both objective and subjective quality of service parameters. In the end, I would just like to give some concluding remarks and a short demonstration of this developed application. Virtual reality has been defined as an advanced human-computer interface that enables the user to feel immersed in a simulated 3D environment. This environment may or may not exist in reality. The user can also interact with this environment. Virtual reality can range from a full-fledged virtual reality system with advanced input and output devices to a so-called desktop virtual reality characterized by high-quality 2D and 3D graphics and integrated multimedia components. In the area of advanced internet services, networked virtual reality services may be foreseen as having great market potential in areas such as entertainment, education, commerce, and so on. Such services impose certain quality of service requirements dictated by rich virtual reality and multimedia content, user perception of real-time interactivity, and a multiple number of distributed users. Specifying these requirements calls for different representations of quality of service at the user and application level, as well as at the communication or network level. This is due to the fact that while a user evaluates quality of service in subjective and qualitative terms, communication level's quality of service is expressed in quantifiable and objective parameters. The modeling and analysis of network virtual reality has been recognized as a difficult research problem, with research mainly progressing in two complementary directions. One direction has addressed the performance of virtual reality end systems, addressing user-based evaluation and human factors issues, while the other direction has addressed virtual reality communications in terms of communication parameters, communication architectures, and suitable protocols. There has, however, been limited research on relating user-perceived system performance with quantitative network parameters. This is where our goal has been to address this area. A set of high-level quality of service characteristics and their mapping to transport-level quality of service parameters has been addressed as applied to our developed application. And an interconnection model that has been proposed in previous work that relates interactions at the user level with transport-level parameters has been used for reference. So I would just like to shortly describe this model. This model shows a mapping of virtual world objects from a user's point of view to the media connectivity level. So when we look at a virtual environment, we see it as a collection of virtual world objects. These objects can be classified as shared objects. These are objects that require replication in order to maintain consistency among distributed users, and as continuous media stream objects, or so-called trans objects. Following the user view level, the following two levels show different levels of composition and decomposition within the application, with the spatial composition level addressing the spatial components of an object's media components, and the distribution and synchronization level addressing temporal relationships between virtual environment objects. And finally, at the media connectivity level, we have a mapping to transport level parameters. Now, in order to make this a little bit more clear, I would just like to show this mapping process. So like we said, from a user's point of view, a virtual environment consists of a collection of virtual world objects. At this point, the distribution of the virtual world remains transparent to the user. Following the user point of view, we have a spatial composition level, where virtual world objects may be classified as either shared objects. These are objects that require replication. They contain geometry in the form of 3D and 2D graphics, and various data types. These can be single data types, such as audio, video, or text, or combined data types. What we see here is a media container describing the spatial components of audio types. For example, the position of sound in a virtual world. Trans object refers to continuous media stream object. In this case, we have no replication. Instead, a streaming connection is established between source and sink. There's no spatial component involved. At the distribution and synchronization level, we are addressing temporal relationships between virtual environment objects. There exists a temporal relationship between replicas on distributed machines as relating to shared objects. Interstream synchronization is necessary for all streams, whether they're mapped to shared object or trans object and displayed directly to the user. And for streams that are temporally related, synchronization between the streams is necessary. And finally, at the media connectivity level, we see a mapping to transport level parameters, where so-called media profiles represent the communications requirements of the different media types that we see here. In order to address virtual reality and internet services in the as related to quality of service issues, In the scope of this paper, we have developed a simple prototype application that we called Virtual Audio Chat. Virtual Audio Chat enables real-time audio communication over the internet between a multiple number of users by way of a virtual reality interface. The application consists of three basic components. The user interface is designed as a virtual reality modeling language mobile phone model. A Java applet opens a real-time transfer protocol-based audio conference implementing the Java Media Framework. And a modified session directory tool was used in order to schedule and announce our audio chat on the internet. The way it works is that a user wishing to initiate or organize this audio chat starts the session directory tool and defines any necessary parameters, such as who is organizing the chat, when it is taking place, and which media will be comprising the session. This session is then announced, and users running the session directory tool will receive notification, and if they choose to join, will launch a web browser and download the virtual reality modeling language mobile phone model. The user will then enter onto the mobile phone using virtual keys the multicast group address designated by the session directory, and in this way join the audio chat. This will be shown more clearly at the end with a short demonstration. So, as I said, the user interface is designed as a VRML mobile phone model. VRML is a file format for describing interactive 3D worlds on the internet with integrated multimedia components. It provides the means for describing static and dynamic 3D and multimedia objects with hyperlinks to other media elements. It also provides the means for implementing various user interactions and dynamic animations, some of which we see here on this slide. So the user can, using the mouse pointer, click on the virtual keys to enter the multicast group address designated by the session directory. By clicking on the active flip, the user can trigger an opening and closing animation. And also what we see here is a scroll bar, which actually represents a virtual media data buffer. During the audio chat, by setting the position of the scroll bar, the user can control the amount of data that is processed, that is buffered prior to being passed on to the next processing stage in order to reduce the effects of delay variations or jitter. After entering the multicast group address, the user joins the real-time transfer protocol-based audio chat. Rtcp provides end-to-end transport services for data with characterized by real-time characteristics such as interactive audio and video. Rtcp is based on application-level framing design principles, meaning that the application is the one that's taking care of data loss discovery, and we can use more unreliable protocols at the transport and network levels. Here we have UDP. Rtcp does not provide resource reservation and does not provide quality of service guarantees for real-time applications. It works in conjunction with the real-time transport protocol control protocol. Rtcp monitors data sessions and provides the transport of control data. Generally, so-called receiver and sender reports are sent containing statistics relating to current quality of service, such as inter-arrival jitter and packet losses. So in this way, we can monitor a session. And finally, we've heard a little bit today about the MBone tools, one of which is the session directory. So the session directory is a tool for scheduling and announcing multimedia sessions on the MBone. We decided to modify the session directory tool in order to use it for our purposes. What we see here is the user interface that is part of the session directory in the case when a user creates a new session. A session contains various media components such as audio, video, and text. We modified the session directory tool by enabling a new media type that we called VRML audio. So a user running this tool can organize a session containing this media element, and another user receiving notification can then, when they decide to join this session, will launch a web browser and download the VRML mobile phone model that we previously saw. Going back to the reference model that we described at the beginning of the presentation, we can see now how we can relate it to our developed application. So as we stated, the virtual environment consists of a collection of virtual world objects that can be classified as either shared objects or trans objects. In our case, the mobile phone model and this virtual scroll bar may be considered shared objects containing geometry. Here, replication is necessary only during initial download. Afterwards, each user can manipulate his or her own virtual environment. And a trans object contains the audio streaming with no spatial component, in this case, enabled. Stream synchronization is necessary and is implemented in the RTP protocol. In this case, profiles 1 and 2 refer to the protocol stacks being used, with profile 1 being HTTP over TCP over IP, and profile 2, RTP and RTCP over UDP and IP. Quality of service in this case was best effort due to the fact that resource reservation was not enabled in our laboratory network. A performance evaluation of the developed application was performed, where we addressed both communication level parameters and user level characteristics. A group of 9 representative users was assembled and asked to evaluate our application. Measurements were performed of RTP and RTCP packets throughput, and a set of high-level quality of service characteristics, namely interactivity and immersion, were evaluated in terms of quantitative, communication, and application level parameters. RTP and RTCP packet throughput was measured using the Ethereal Network Protocol program, packet program for capturing and displaying packets. We asked 4 users to simultaneously take part in the audio chat and filtered packets to determine the throughput generated by each user. This is what we see here on this slide, the throughput generated by one user during this audio chat, with the red line depicting RTP traffic and the green line depicting the occasional generation of RTCP packets. The beginning of packet generation indicates the moment when the user joined the audio chat. It may be a little hard to see, but it occasionally oscillates around approximately 39,000 bits per second. And we see the occasional generation of RTCP packets carrying information with regards to current quality of service characteristics. In previous work, a set of high-level quality of service characteristics has been described for the purposes of relating user-based interactions at the user level and user-perceived quality of service with quantifiable communication and application level parameters. One such quality of service characteristic is interactivity, defined as a user's evaluation of the ability to interact with objects in the virtual environment and other users in the environment, and also the extent of such interactions. In our case, an empirical approach was used using a questionnaire where users were asked to evaluate our developed application. As regarding interactivity, users evaluated functionality, interaction techniques, and navigational abilities. Measurements performed in this manner can then be used for the purposes of application improvements as perceived by the user. Interactivity can be quantified as a combination of variables representing sensory input support, navigation, and a user's representation in the virtual environment. What we see in this table is our quantitative interactivity parameters and their values as relating to our developed application. In our case, tracking, we have 2D pointer mouse tracking, and the virtual keys on the mobile phone may be considered virtual controls. Navigational techniques were implemented in the VRML plugin browser. In this case, the user can choose between examining, flying, and walking modes. No user appearance was enabled with only a simple viewer. And in this case, interactions refer to the user's ability to select and manipulate the objects in the environment. Another high-level quality of service characteristic is immersion. Immersion is defined as the presentation quality of the multisensory information perceived by the user as the 3D synthetic environment. Immersion can be quantified once again as a combination of variables representing a visual, auditory, and haptic immersion. Once again, an empirical approach using a questionnaire was used where users evaluated visual quality of the mobile phone model and auditory quality during the audio chat. Some of the quantitative parameters referring to visual quality include color, resolution, level of detail, frame rate, and so on. In our case, we concentrated on auditory quality with some of the quantitative parameters shown here on this slide. Sound quality can be described as phone quality. And in our case, no spatialization was enabled. As I stated, this audio stream can be considered as a trans object or a continuous media object in our virtual world. Key network parameters influencing the quality, auditory quality as perceived by the user, are delay, jitter, and packet losses. In our case, during the audio chat, we ran a tool called Rtcp Mon that works by reading Rtcp packets that are generated by the users, and this tool then sorts out, filters, and displays statistics from these packets as related to inter-arrival jitter and packet losses. So what we see here is a picture of the main Rtcp Mon window with the rows representing receivers and the columns representing senders. So these are current statistics as related to inter-arrival jitter at this point. By running this tool on a separate machine, an administrator can monitor a session and diagnose any problems that could be related to the session. So in conclusion, I'd just like to give a quick overview. So in the scope of this paper, we developed a simple multi-user virtual reality and web application. The whole overall approach that was used from the model to the implementation is general, as has been described, and may be applied to a wide range of such services. And a performance evaluation was conducted addressing both subjective and objective quality of service parameters. And results that have been achieved can be used for such purposes as resource reservation at the communication level, as we saw with measurements of packet throughput, and for the purposes of application improvements as perceived by the user. So at this point, I would just like to show you a quick demonstration of the developed application just so that you can see what I was talking about. So what I'll show you now is a short video clip, what it would look like if a user were to run the session directory tool, organize and announce this audio chat, and then what it would look like to join this audio chat and actually enter the multicast group address onto the mobile phone, and in this way join the streaming session. Okay, so what we see here is the main session directory window. We see some previously announced sessions. By clicking on New, the user can now create a new session by entering the session name. It might be a little hard to see. It says Virtual Audio Conference, and giving a description of the session for users that might wish to join. In this case, it says everyone is invited. So here we are entering information about the session. Next, what kind of session it is, whether it's test, meeting, broadcast, depending on how interactive the session is. We leave this a test. Next, the time, the date, the time, and the duration, so that users know when to join the session. The distribution scope, how far we want the session to be announced, locally, regionally, worldwide. The media comprising the session, it's hard to see, audio, video, text, so on. Here we see we added at the end verbal audio, so now we're organizing a session containing this media element. Contact information from the organizer, in this case email address, phone number in case the organizer needs to be contacted. Security parameters, this we did not address in our case, so we'll just skip. And finally, the session details, so the organizer can review this and then choose to accept and announce the session if everything is okay. So now we see other users will receive notification that the session has been announced. By clicking on it, they will see all the necessary information with regards to description and address. By clicking on Join, they will download the mobile phone model. So here the user can manipulate the model, This is opened in a Vermo browser, Cortana in this case, so we see some of the interactions that have been enabled. The user can view the model from any angle. And what the user needs to do in this case is enter, using the virtual keys, the multicast group address that has been designated by the session directory. So we'll see here, we open once again the session directory window. It's hard to see, but in this window, the session directory window, we have information concerning the address and port number that the user is now entering onto the virtual mobile phone in order to enter the audio chat. So once the user enters this address, we'll start a streaming session on this address and listen for any incoming streams. And once again, we see this media buffer or scroll bar that we have here, which the user can use by moving it, can reduce any effects of jitter or delay variations that may be detected. Okay, so the user has entered the number now and listens to see. It says open RTP session.
Hi, this is Leah. Can you hear me?
Hi, Leah. I can hear you, but the sound is a little interrupted.
Try maybe increasing the buffer size.
Okay. It's much better now.
Okay, so this was just a little act to show what this would look like. But so I hope this made it a little bit more clear what I was talking about. And with this, I'd like to conclude the presentation. And if there are any questions, I'd be happy to answer.
Thank you very much, Leah. And sorry, questions from the floor? We'll need.
No questions.
Well, then maybe you. Well, you mentioned user-based evaluation and also. The mapping of the various objects to the network parameters and so on. So, can you maybe can you give some more details about that? But the results of this.
Okay. Well, user-based evaluation is very important in applications such as, for example, this one, or especially when we were looking at a virtual reality, because inherently the user of the application is human, and a feeling of real-time interactivity and of being immersed in an environment, or that the environment is similar to real life, is very important. So we're focusing here on the user. User-based evaluation techniques include both objective measurements with quantitative parameters, some of which we have described in this case, and also subjective measurements, mostly in the form of a questionnaire, are important. In this case, we're looking at usability evaluations. There has been much work in this area. So it is evaluations in the form of subjective measurements are important in order to improve also user interfaces. And users are asked questions with regards to functionality, ease of use, ease to learn how to use this, and so on. So what we saw here was a mapping of high-level quality of service characteristics that we mentioned, interactivity and immersion. Also a third quality of service characteristic is plausibility. The user's acceptance of events happening in the virtual environment as corresponding to actual real-life laws of physics and so on. For example, if I drop a ball in a virtual environment, that this ball actually drops. And so we saw this mapping of two parameters in this case.
And then second question, would you consider to integrate this study with some objective performance measurement, or maybe to address end-to-end performance? Is that something that's out of your interest?
We have done work in this area where we have performed measurements also of end-to-end performance that we have not described here. So with various applications, one of which was this one. We also addressed multi-user environments where we addressed the issue of delay. For example, when we have a multi-user environment, the delay is a key factor. When one user performs a certain action, that this becomes visible to all other users in practically real time. So the user perception of real-time interactivity is very important. So yes, we have performed measurements in this area.
Right. Okay. Yes, there are some more questions. Lada first. Yeah, this one, sorry.
Thank you. Have you found any real advantage in terms of user perception of this approach in comparison to the more standard ways of audio chat and video conferencing and things like that?
Well, in this case, this is not meant to be a commercial product. We just addressed this as an example of an interface. We did ask users during the evaluation whether at all this mobile phone model added to the feeling of an actual audio chat, and they actually said that it did. So this is just an element to add to the reality of what it would look like. But so.
Maybe this is not very technical and not very relevant, but how did you choose those representative group that you performed the test on?
This was a group of students that we had at the university, relatively random. So there was no real methodology that we used. They were basically people that had never seen this application before. So we brought them in and asked and described to them shortly the procedure of what it would look like, and then they ran the session directory tool and the mobile phone, and so it was rather random.
Any more questions? No, I don't see any more questions. Okay. Thank you very much again, and I want to thank all four speakers for their very good presentation. Unfortunately, Greg is not online anymore, but thank you very much. And thanks to the floor.